All right, so in this equation, we have x times x times x plus x is equal to 30. So my only variable here is x, so we know that we're going to solve for x. So for my solution, what I'm first going to do is start by subtracting 30 on both sides. So if I subtract 30 on both sides, I get x times x times x plus x minus 30 is equal to 0. Now from here, I can rewrite this as x to the power of 3 plus x minus 30 is equal to 0, because x times x times x is the same thing as x to the power of 3. And now, a lot of people would think this is a quadratic equation, but this is a power of 3, not a power of 2, meaning we can't use the quadratic formula to solve this equation, or we can't simply use the normal method of factoring. So to actually solve this, what I'm going to do is rewrite negative 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. And notice how we have something to the power of 3 plus that same number and another something to the power of 3 minus that same number. So now I'm going to group the two powers of 3's. So I get x to the power of 3 minus 3 to the power of 3, plus I'm going to group the powers of 1, so plus x minus 3. Now from here, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So I get x minus 3 times x squared plus 3x plus 3 squared, which is 9, plus I have my x minus 3 at the end, is equal to 0. Now from here, notice how both of these terms have x minus 3 in them. So what I'm going to do is factor out x minus 3. So I get x minus 3 times x squared plus 3x plus 9 plus 1 is equal to 0. And this is equal to x minus 3 times x squared plus 3x plus 10 is equal to 0. And now I have two equations from this. I get x minus 3 is equal to 0, and x squared plus 3x plus 10 is equal to 0. So for x minus 3 equals 0, this is fairly simple. All I have to do is add 3 on both sides. So then these two cancel out, and I get x is equal to 3. So this is one solution of x. Now, for x squared plus 3x plus 10 is equal to 0, this is a quadratic equation, meaning I can use the quadratic formula to solve this. So recall that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get x is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And now this is equal to negative 3 plus or minus the square root of 9 minus 40 over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. And negative 31 is the same thing, the square root of negative 31 is the same thing as the square root of 31 times the square root of negative 1. And if you guys already know, the square root of negative 1 is equal to the imaginary number I. So I get negative 3 plus or minus the square root of 31i over 2. And this is actually two solutions. X is equal to negative 3 plus the square root of 31i over 2, and x is equal to negative 3 minus the square root of 31i over 2. Now from here, going back, my original equation was x times x times x plus x minus 30 equals 0. Well, these two are complex solutions, so we can't really check them, and they are not actual solutions. But what we can check is 3. So if we plug in 3, we get 3 times 3 times 3 plus 3 is equal to 30, which turns into 27 plus 3 is equal to 30, and I get 30 is equal to 30. Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this, I'm going to first write 9 as 3 squared. So I get 3 to the power of x to the power of 3 over 3 squared to the power of x is equal to 81. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 3 over 3 to the power of 2 times x, so 3 to the power of 2x, is equal to 81. I'm going to rewrite as 3 to the power of 4. So now notice how I have everything in the base of 3. So this is going to make it much easier to solve. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 over 3 to the power of 2x is going to equal 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. And now if I subtract 4 on both sides, I get x to the power of 3 minus 2x minus 4 is equal to 0. Now we have an equation here, and this isn't a regular quadratic equation because we have a power of 3 here, and we have a missing power of 2. We don't have the power of 2. So to actually solve an equation like this, what we have to do is we have to test out values, and then once we get a value that works out, we have to use that one value to find all the remaining values that are solutions to the equation. So let's first start out with 1. If x is equal to 1, then I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8. 8 minus 2 times 2 is 4, and 4 minus 4 is 0. So this does equal 0. So 2 is a solution. To be more precise, x equals 2 is a solution, meaning x minus 2 is equal to 0. So now what we're going to do is we're going to divide x minus 2 with x to the power of 3 minus 2x minus 4. So I get x to the power of 3 minus 2x minus 4 over x minus 2. And to solve this, we're going to have to use synthetic division, and if you guys don't know what that is, I would recommend watching a YouTube video on it. So our coefficients of our numerator is 1, negative 2, and negative 4, and then we have a 2 over here. I'm going to bring down 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 sorry, I actually did something wrong. We should have a 0 in here because, remember, we have a power of 2. So because there's no power of 2 here, we just put a 0. Now, if we bring down 1, we get 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. negative 2 plus 4 is 2, and 2 times 2 is 4, negative 4 plus 4 is 0. So we have a remainder of 0, and we get x squared, our coefficient is 1, plus 2x, coefficient is 2, plus 2 at the end. So I get x squared plus 2x plus 2 is equal to this. And this also means that x minus 2 times x squared plus 2x plus 2 is equal to 0. So for this equation, I get x minus 2 is equal to 0, and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2, and we already got this solution before, so this is no surprise. Now for x squared plus 2x plus 2 equals 0, to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a, so 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus a, which is negative 4, over 2, which is equal to negative 2 plus or minus the square root of 4 times negative 1 over 2, which is equal to negative 2 plus or minus 2i. Square root of negative 1 is the same thing as I, over 2, which is the same thing as negative 1 plus or minus I. So my three solutions to the equation are x equals 2, x is equal to negative 1 plus I, and x is equal to negative 1 minus I.